In this video, we're going to find length of a curve. So before we do that, let's review, find the distance between 2 points. Let's call this x1, y1, and let's call this x2, y2. And how do you find the distance between these 2 points? And notice this is a straight line. Well, let's draw a right triangle. So the length of this will be y2 minus y1. And what about this right here? That will be x2 minus x1. And let's call this d, the hypotenuse. And that's what we want to find. So d squared, using the Pythagorean theorem, d squared will be quantity y2 minus y1 squared plus quantity x2 minus x1 squared. So d will be, it's positive negative, but length cannot be negative. So it's just radical, positive radical, quantity y2 minus y1 squared plus quantity x2 minus x1 squared. Now, I'm going to call this right here delta y because that is a change of y. And I'm going to call this delta x because that is a change of x values. So when we substitute, we end up getting d equals square root of delta y square plus delta x square. And you could change the order, and you could say it's a square root of quantity delta x squared plus quantity delta y squared. So you need to keep this in mind as I show how to find the length of a curve. So let's say you have a smooth curve. How would you find the length of this smooth curve? Well, idea behind it is we're going to break it into little small segments. We're going to break into small segments so that each segment, when you zoom in, I mean, it's so many segments so that it's like to the infinite. We're going to bring it to infinite number of small segments. When you zoom in, it's going to look like a straight line. So basically, we're going to find the length of each segment, which looks like straight line, and add them up. And do you remember how we found the area underneath the curve? Remember how we broke it into little small rectangles? And then we add up all the infinite number of rectangles to find the area underneath the curve? Well, now we're going to break it into small segments and add up all the length of small segments. So that's what we're doing. So each of the segment had a length of radical delta x squared plus delta y squared. So what I'm going to do is I'm going to rewrite it as radical delta x squared over delta x squared plus delta y squared over delta x squared, the whole thing, times delta x squared. Okay, see if this makes sense. When you distribute the delta x squared, they cancel out, so you end up getting this. I just rewrote it. Now, why did I write it like this? Well, think now you could simplify as square root of, that becomes 1. And that becomes quantity delta y over delta x squared. And then delta x squared comes out from the radical. You just get delta x outside the radical. Now, if you recall, delta y over delta x is like dy over dx. So we could write it as 1 plus quantity dy over dx squared. And the delta x is like dx. So what's happening is that this represents one line segment, but we're adding infinite number of line segments. So the length of a smooth curve will be the integral from a to b, square root of 1 plus, instead of dy over dx, I'm going to put f prime of x, square, and then dx. So this is a formula that will give you the length of a curve, and we're going to look at some examples. So let's say you want to find the exact length of the curve of this y from 0 to 1. So what you need to first do is find y prime, the first derivative. So you get 3 over 2 times 4 radical 2 over 3 x to the 1/2, and then root of negative 1 is 0. And then let's simplify this. You end up getting 3 cancels out. So 4 over 2 is 2 radical 2 x to the 1/2. So now all we got to do is plug it into the formula. The length will be integral from 0 to 1. Square root of 1 plus quantity f prime of x, which is 2 radical 2x to the 1/2, that whole, and then this square, and then there's a dx outside the radical. So this is your setup. And once you have this setup, all you got to do is now use your graphing calculator and find the answer. And the exact answer will be 13 over 6. However, when you use your calculator, your answer will be in decimals. Now you got to find the length of the curve y equals sine x from 0 to 2 pi. So basically, we need to find the length of this curve right here from 0 to 2 pi. So again, we need to find the derivative of y, which is cosine x. So now the length of the curve will be integral from 0 to 2 pi radical 1 plus quantity cosine x squared dx. And again, you could use your graphing calculator, and your answer will be 7.6403. It's always good, safe to go to 4 decimal places for your final answer.